Hello everyone. Here is our project. Plant disease detection using conventional neural networks. These are all our team members. I, Priyanka, Shivasai, Tejeshwa, Tulasi, Neelima. Here are the roles and responsibilities. I and Tejeshwar is going to take care of development part. Priyanka is going to take care of model architecture. And Shivasai is going to take care of data acquisition and pre-processing. Tulsi is going to take care of model training and validation. Nilma is going to take care of quality analysis. Okay, let's get into the project. Actually, this project is mainly useful for farmers to find the to detect the health of the plants. Like normally, what the farmers do is, if a plant is affected by any disease or any virus, they used to estimate the disease and they used to fertilize the they used to fertilize. Uh, so sometimes the estimation may go wrong. So the plant will not produce the good crop, or sometimes in some cases the plant may die. So to prevent this, uh, this application will help to find like what the fertilizer need to be given, and the what at like total health report of the plant, and what are the fertilizers need to be given, and what at what time the water is need to be given, and what are all the pesticides need to be given. It shows all the detailed report, not only for the farmers. So like in our garden, if a plant is affected with any disease, like we used to randomly estimate the disease and we used to spray the fertilizers. But it may die, or it won't produce the good flowers or the fruit or something. So uh, at the time this application will help. Whenever you scan the leaf, the whenever you scan the leaf, it will show the all the health report and what are the disease caused. But but see, but all the here in as shown in here in the image, but all the diseases look similar. All the viruses look similar. So we couldn't estimate like what the exact virus or exact disease caused to the plant. So in that cases, this, in that cases, this application will be helpful to find the what the disease is caused, and what are all the fertilizers need to be given, and the water total health report of the plant. And from here, my friend Priyanka will take over.
I'm Priyanka. So, how to prevent this from happening? To prevent this situation, we need a better and perfect guidance on which fertilizers to use to make a correct identification of diseases and able to distinguish between two or more similar type of diseases individuals. This is where CNN comes hand. In short, CNN. Convolutional neural network. In deep learning, a convolutional neural network is a class of deep neural networks most commonly applied to analyzing visual image. They are also known as a shift invariant or a space invariant artificial neural networks. Based on the shade weights, architecture, and translation invariance characteristics. These are the characteristics of CNN. And this is an architecture diagram. It shows leaf disease image dataset. And next comes to data pre-processing, data cleaning, EDA. And next we have used the algorithm of model selection, CNN. And next comes to model evolution and GUI, image input, output, best model, and diagonals. This is a sequence diagram which we have used GUI, user, processor, model, and label. This comes to input data, pre-processing, model fit, model evaluation, prediction, and probability, and display output. And these are the tools which we have used in this project: Flask, Keras, PyCharm, Jupyter Notebook, OpenCV, Python, and TensorFlow. The next slide will explain my friend.
Hello everyone. So in this slide, we can see features in our minimum valuable product in this project. So the first one is creation of user interface for user authentication using login option. So after that, after successfully authentication, it will redirect to home page. So when you redirect to the home page, you can see some menu options like home, EDA, model parameters, and detector PDF report. So the next one, option to upload image for disease dissection. And the last one, you can log out from the application. Next slide, please. So here are the some personas. So the first one is farmer Maria. So here Maria is a small scale farmer who grows crop such as tomatoes, potatoes, and peppers. So she needs to monitor her crops regularly for signs of diseases to prevent crop loss and ensure a healthy harvest. So she needs a user-friendly interface that allows her to easily upload images of her plants and receive quick and accurate diagnosis. The motivated Maria is to increase her crop yield and profitability by identifying and treating plant disease early. So the next person is the agricultural extension officer. So he works an agricultural extension officer in a rural area, so providing advice and supporting to local farmers. So he needs a one tool that can assist him in identifying plant diseases so accurately during his visits to farmers. So he also requires to access to educational resources and recommendations for disease management practices. Next slide, please. So here, third person is the researcher. So here, Dr. Patel is a plant pathologist conducting research on crop diseases. So he needs to require a platform that can analyze large data sets of plant images to identify trends in disease and monitor the spread of new pathogens. So, access to advanced analytics tools and the ability to collaborate with other researchers are also important. So, he is motivated to advance scientific knowledge about plant diseases and develop effective strategies for disease management and control. So, the last one persona is the agri-tech entrepreneur. So she is an entrepreneur who runs an startup company focused on developing agriculture technology solution. So she needs a plant disease detection system that can be integrated to mobile applications or IoT devices for widespread. So adoption by farmers. So she also requires access to APIs or SDKs to customize the systems and integrate it with other agricultural technologies. So from next slide, my teammate will take care, Teja.
Hi. Here we have like a whole task we are completed in this project. See, and in this we discussed like a few tasks in the split one. Yeah, split one. Yeah, here we are discussed in the split one. Like we discussed in the split one to open application of the browser and the login page of the application, and we discussed about welcome our home page after successfully logging into the page. And here we are given access to the EDA menu to see the data analysis and the project, and then also we given the access to the model parameter menu to see the various pages, and also we given the access to detector menu. And these are our tasks in the split one. And next we are going to for the yeah, here we did like some matrices in the first split, and we completed most of the work in the split one, and we're going to complete remaining task in the split two. Yeah, these split two task we are going to complete in the days like next.
Next, coming to stories. Here, the first acceptance criteria is web browser. Here, as a user should have the website URL to open the application in the browser. Scenario: user type the URL in the web browser. Given users user of the application. When user try to access the application in the browser, then user should be able to access the application. Next acceptance criteria is login page. As a user should be able to see the login page of the application. This is a scenario. User types the username and password, and when user try to log into the application, then user should be able to log in. Next acceptance criteria is home page. Here, as a user should be able to see the welcome or home page after successfully logging to the application. First scenario, try to access the home page. When user try to access the home page, then user should be able to see that. Next slide, please. Next, as a user should be able to see all the menu options in the application. Here to see the menu option, when user try to access the menu option, then user should be able to access the same. Next acceptance criteria, home page. User should be able to access the EDA menu to see the data analysis of the project scenario. To access the EDA menu option, when user try to access the EDA menu, then user should be able to access the EDA menu. Next, user should be able to access the model parameter menu. Here, to access the model parameters menu, user should try to access the model parameter menu. Then user should be able to access the same. Next slide, please. Next, coming to test cases. The first test case, verify login functionality with correct credentials. These are the test steps. First, navigate to the URL. Next, we are gonna enter the correct username and correct password. Then we click on the submit button. Here, these are the test results. User navigates to the login page, and then user can enter the username and password. Then home page will open. Next test case is verify login functionality with incorrect username. Here, we enter the incorrect username and correct password. Then we click on the submit button. These are the test results. User navigates to the login page and then enters the incorrect username and correct password. Then we will get when we submit, click on the submit button, we gonna display an error message. The page displays an error message. Next test case is verify login functionality with correct username and incorrect password. When we navigate to the URL, the web page, when user enters the correct username and incorrect password, and we click on the submit button. Here, we'll get an error message displayed on the web page. Next slide, please. Next, coming to working agreement, team working agreement. Here, our project aims to address the lack of local plant diseases, expertise by providing immediate diagnosis through image recognition. We will leverage a combination of learning and supervised learning techniques to detect plant diseases from publicly available images. These are the team members' roles and responsibilities. This was already explained by my teammate. These are our project goals. We are going to create an image recognition system that identifies plant diseases and will provide accurate and timely diagnosis to the farmers and extension officers. These are the communication guidelines we have used. We have conducted the regular meetings to discuss progress, challenges, and the next steps. And next Slack channel, we have used day-by-day communication and for the quick updates. And we have used email for the formal communication or for sharing important documents. We have maintained a positive and respectful tone in the all interactions. Next is decision-making process. These are the decision-making process we have used, like consensus, voting, and the project manager will make the final call. And next, work schedule. We are following the 2 week sprint cycle. Next week, each team member will take ownership of the specific task, and we are adhered to agreed upon deadlines. And next is code of conduct. We are following professionalism, timeliness, and collaboration. Collaborate openly and share knowledge within each other. And next is version control. We are using GitHub for version control and collaboration, and we are using a branching strategy. And this is the documentation we are using. Next slides will be continued by my team.
Retrospective. What went well? We as a team have planned to keep our objective simple to finish and produce what was expected. Team has a good time working together. Active response from the team to get involved in tasks with clear thoughts. The main key was participation and motivation to complete the task within the deadline, and every member knew what they had to do. We had several discussion sessions. Overall, like every meeting session is effectively used to gain progress and complete sprint on time. What could be improved? We frequently try to communicate about to discuss about the project and the advancements even after the every sprint completion, and setting up the time limit for the task and learning from previous semester student sprint performance to make improvements and where can we do better. What we plan to commit for the next sprint. To maintain consistency in performance and improvement is the key. Previous student sprint retro can be helpful for improving team balance in which areas team is lacking and where we can work according to that. Previous retro stats can be helpful in filling the gaps of next sprint. And this is the user login page for our project. And this is the home page. And this is the link for the wiki page. Thank you very much.